Okay, here's part 3 of the Chapter 5 review. We'll probably most likely do 17 to 23, and then the last part will be the integrals 24 to 36. Okay, use the first derivative test to show that this function is strictly monotonic, which means strictly monotonic, it's increasing or decreasing over its domain. And if it is increasing or decreasing over its entire domain, then it has an inverse. Alright, so f prime of x is going to be equal to a negative 1 minus 3x squared. Set that equal to 0. Now at this point, I mean, you can solve this and see what ends up happening, but I know that no matter what value I substitute in for x and square it, that's going to be a positive. So I'm going to have a negative 1 minus 3 times a positive number. Well, that's going to be a negative. A negative 1 minus a negative number is going to be negative. So this is always going to be f of x. Prime of x is always negative. Therefore, it is strictly monotonic and has an inverse. Okay. Relative extremis. So first derivative, set it equal to 0, find the critical numbers, and test that. And we only need to test for where x is greater than 0 because the ln of x, that function's never, the x values are never going to be less than, because it looks like this, right? So your x values are never going to be less than 0. Alright, so we only need to test everything greater than 0. Alright, so the derivative of this. The 2's would cancel out, so I'm going to get x minus 1 over x. I'll simplify that a little bit to over x, and that's going to be an x squared minus 1. So it's undefined at 0, but again, we're checking everything greater than 0. But your critical numbers are going to be x equals 0 for where it is undefined, and in the numerator, that'll give me a 1 and a negative 1. And again, I only need to check everything greater than 0 for this function. Alright, so I'll put all the critical numbers on there, but alright, so I'm going to do f prime of a half, and this is my f prime number line, and f prime of 2. Alright, so I'm going to substitute a half in right here. So when I put in a half, that's going to be a 1/4, so the numerator is going to be a negative number, and the denominator is going to be positive, which is going to make this negative, so it's decreasing. And if I put a 2 in, numerator is going to be a 4 minus a 1, so that's going to be a positive over a positive. So we have a relative minimum value at 1 comma, and I got to plug that back into the original function. So that's going to be 1/2 minus the ln of 1, which is going to be a 0, so that's a half. And there's my relative min. Alright. 19, equation of the tangent line. Alright, and again, kind of the same idea. We just need to find the slope. So the function is y equals x times ln of x. Going to do a product rule. So the first times the derivative of the second plus the derivative of the first times the second. Do some simplification. So that's a 1 plus ln of x is equal to y prime. And yeah, and then we're going to substitute in e in for x. So y prime is going to equal to 1 plus the ln of e. That's 1. ln of e is also 1. So y prime at that point e comma e is 2. So that's my slope. So the equation of the tangent line is going to be y minus e equals 2 times the quantity of x minus e. Done. All right, write the equation tangent line. Another one. Just the, e to the u times u prime. So y prime is equal to e to the u times u prime. And I'll just make that a little bit nicer. Substituting 2 in for x. So that's going to be 2 times 2 e to the 2 squared, which is 4. So that's going to be 4e to the 4th, which is y prime at 2, which is our slope. So y minus e to the 4th equals 4e to the 4th, and then x minus 2. You can leave it like that. Done. I got to stop saying done. All right, what number is this one? 21. All right, number 21, find the area bounded by that function. And you don't even need to graph it. It's bounded by x equals 0, x equals 1, and y equals 0. I will sketch the graph for you. All right, so that graph will look like this. There's the ordered pair 0, 1, and it just goes this way. So we're going to find the area bounded by x equals 0, which is this line, y equals 0, which is this line, and x equals 1, just assuming where that is. So we're going to be finding that area there without a calculator. So we're going to integrate from 0 to 1 of e to the negative x dx, and yeah, so I'll do u substitution. So u is equal to negative x, du is equal to negative 1 dx. I'll bring the negative out in front, so it's going to be a negative du is equal to dx. So when I rewrite this, there's going to be a negative out in front, 0 to 1, e to the u du. And the integral of e to the u is e to the u. So it's going to be a negative e to the u, which is negative x, and we'll evaluate that from 0 to 1. All right, so we do f of b minus f of a, so it's going to be negative e to the negative first, minus, actually that'd make that a plus, because the negative out in front of that, and the f of b minus, so that minus and that minus make that a plus. And we'll plug in a 0, e to the 0 is 1. So this is going to be a negative 1 e plus 1. And the last two is just average value. Right, find the average value of the function. So this is 1 over b minus a, integrate from a to b of f of x dx equals the average value, which is f of c. All right, so 1 over b minus a, so 1 over 2, integrate from 1 to 3 of 1 over 3x minus 1 squared times dx. And we'll use some u substitution here. So u is equal to 3x minus 1. du is going to be equal to 3 dx. So du over 3 equals dx. So we'll bring out the 1/3, so that'll give me a 1/6. Integrate from 1 to 3 of 1 over u squared du. And I'm going to rewrite that as 1/6. Integrate from 1 to 3 of u to the negative second du. I'm just going to come over here. I'm only going to do one of these two. They're pretty similar. You can check the answer key to see how to do number 23. So 1/6 times the quantity. So that is going to be, add 1 to that, so it's going to be u to the negative first over negative 1, and we'll evaluate that from 3 to 1 in a second here. So 1/6 times 1 over u, 1 over u, which is 3x minus 1. And again, we'll evaluate that from 1 to 3. So 1/6 times the quantity, plug in a 3, that's 9 minus 1, so that's 1/8 minus, plug in a 1, 1/2. So the final answer, I'm not going to do all the simplification, I'm just going to write down the answer, is 1/16. Okay. We're going to stop there for this video, and we'll finish up the integrals last.